Alright, in this video we will be continuing our discussion on trig ratios of any angle. So in the last video and in the last lesson we saw that different trig ratios are positive or negative depending on which quadrant we are in. So the problem that we're faced with here is we're told that sine of theta is equal to -7/25. We want to figure out which quadrant can the terminal arm be in. Now, what you need to think of here, so I have it written out, so where is the sine ratio negative? Now, if you remember, A for all ratios are positive in quadrant 1. S for sine is positive. T, tangent is positive in this quadrant, and C for cosine. Now, if sine is positive in quadrant 1 and quadrant 2, that means that sine would be negative in quadrant 3 and 4. So what I can do here is, to draw my diagram, I can draw terminal arms. This angle could be both in quadrant 3 or in quadrant 4. Now, for the purposes of our video here, I'm going to zoom in on these quadrants so we don't really have to look at the top two quadrants. Just make this a little more clear for us. Alright, so we can draw a triangle as we saw by drawing a vertical line to the x-axis on both sides here. Let me get that straight. Alright, so there we go. So those make 90-degree triangles. And now I can label some of the sides. So what I know is that sine is -7/25. So sine again is opposite over hypotenuse. So if we're looking at this angle here and this angle here, the opposite sides would be -7, and -7 is opposite to this angle. So this makes sense because -7, it is below the x-axis, so that is 7 units down, 7 units down. That makes sense. And the hypotenuse is +25. So remember our R values are always positive, so +25 is the hypotenuse. Now, I still want to figure out what the x values are to fill in my diagram, and we are going to need to know those x values anyways in order to figure out the second part of the question, which is finding cotangent theta. Alright, so to figure out the value of x, we're just going to use the Pythagorean theorem. So x squared would be equal to the hypotenuse squared subtract the side of -7 squared. Now, that would work out to be, we got the square root of 576 because I want to square root both sides. So x works out to be, oh look at that, perfectly works out to be +24. Now wait a minute, what happens when we square root both sides of an equation? Oh, that's right, we get a positive or a negative answer. Now this is very, very important for this sort of question because now if you take a look at our diagram, this length right here for x would be +24. But I can't label this one as +24 because it's on the left-hand side of the y-axis. So this one would have to be -24. So you got to be careful when you're square rooting like that. You get two different answers. Alright, so I figured out the two quadrants that the angle can be in. I've labeled all three sides of my triangle. So now I can figure out what cotangent theta is. Now, cotangent theta, remember, is the reciprocal of tangent. So instead of opposite over adjacent, we're looking for the adjacent side over the opposite. Now, we actually are going to get two different answers here for cotangent theta because we have two different values of x, +24 or -24. So in quadrant 3, this corner right here, the adjacent side would be -24, so cotangent theta is equal to -24 over, and then the opposite side is -7. Now looking at this answer, remember that the two negatives would cancel out, so cotangent theta would be +24 over 7. So remember that tangent is positive in that quadrant, so it would make sense that the reciprocal cotangent theta is also positive. Alright, so we also will have a different answer in quadrant number 4, so this quadrant right here. So again, cotangent theta would be the adjacent side is +24, the opposite side is -7, so 24 over -7 although I'm going to put that negative sign for proper communication in the numerator. So those are my two answers for cotangent theta. Alright, so a different type of question, but using the same strategies as before. We want to find the exact value of sine 120 degrees by drawing a diagram, and we're actually going to have to use those special triangles that we learned last week as well. Now, if you take a look at the xy axis here, 0 degrees would be the positive x-axis, and if we were to have a terminal arm that we rotate around, the positive y-axis would then represent 90 degrees. Okay, if you keep rotating, we got 180 here, rotating, 270 degrees. And then if you rotate all the way around again, that axis actually could represent 360 degrees as well. Now the way that that would look is, if we rotate all the way around, but what the angle would look like is this right here, just to demonstrate that it goes all the way around. That's an angle of 360 degrees. So anyways, while I'm talking about that, we have to be able to draw 120 degrees. Now that won't be in the first quadrant because that's between 0 and 90. So it will fall in the second quadrant because it is between 90 and 180. So the question is by how much? Now if you think that we're starting at 90, we would then have to go an additional 30 degrees, okay, in order to get to our angle of 120, because 90 plus 30 is 120. Now remember though, when we draw our triangles, we're drawing it to the x-axis. So I can draw my line down here, and this angle is the angle that we actually want to examine, the angle that the terminal arm makes with the x-axis. Now if this is 30 degrees between the terminal arm and the y-axis, then what would be the angle left over here? Well, that would be a 60-degree angle. Alright, so what I'm going to look for now is I'm going to look at my special triangles that I have written down, and I know that for a 60-degree angle, root 3 is the opposite side to that. 2 is my hypotenuse, and 1 is my adjacent side. Now you also have to take a look at what quadrant you're in. So because I'm in quadrant number 2, this would be positive root 3 because it's going upwards. The hypotenuse is always positive, but for the x value here, we're going to the left, so that would actually be an x value of -1. So we have to make sure that we are labeling our triangle properly. So at this point, now I can look at what would be sine of 60 degrees for this triangle. Okay, so sine of 60 degrees would be root 3 over 2. Now, it's not going to be exactly root 3 over 2, so again, you have to take a look at your triangle for positive and negative values. So we did label this as positive root 3, and the hypotenuse is positive as well, so it is going to be positive root 3 over 2. Now, if I were to then say as well, okay, let's do cosine of 120 degrees, so I'm still looking at this 60-degree angle right here. Cosine would be -1 over the hypotenuse of 2. So you'd see that cosine of 120 degrees is negative, and we learned before that only sine should be positive in this quadrant, so that makes sense. So that's why it's important to have a properly labeled triangle, because then it will tell you which ratios should be positive and which ones should be negative.